Hi, I'm Gabe Cobb. You've seen me in such fine quality, epic chemistry educational videos as Gibbs Energy, Is It Really Free? And Gibbs Energy Entropy, What Connection Is There? Well, for this particular video, we're going to be looking at the delta G overall of a chemical reaction that's happening. Now in this case, we're not taking into account the temperature or the entropy. We're going to look at the delta G value for each of the components. Now what's nice about this, if you understand how Hess's law works, and again you can see another video for that, it works the same way here in this instance. Because the formula that you would be using is this one right here, where the delta G of the overall reaction is equal to the summation of the delta G of our products minus the summation of the delta G of our reactants. Now in this case here, we're looking at the following data at 25 degrees Celsius, where we have carbon, and I'm going to initial as D for diamond, plus O2 as a gas, and we end up getting CO2 as a gas. Okay, that's our first reaction, and we have a delta G value. This reaction by itself has a delta G value of negative 397 kilojoules, kJs. Now, it's important to notice that when delta G is negative, it is spontaneous, which means that the reaction would be spontaneous. In other words, there's no need to have outside interference. It means that you can go and run the thing. You don't have to put any effort, no oomph into it. It's spontaneous. Now, we have another chemical reaction where we have the carbon that's in the form of graphite. That's why I'm labeling it like this. Plus, again, oxygen gas. It's going to also get us CO2 in the form of a gas. Now, it also happens to have a delta G value. A delta G value of negative 394 kilojoules. So this is the information that we have, and we need to calculate the delta G for the reaction of. We're trying to find, ladies and gentlemen, the delta G for the reaction of carbon in the form of a diamond as it goes to carbon in the form of graphite. That's what we're looking for. And is it spontaneous or is it not spontaneous? That's what we're shooting for here. This is very, very similar to working the Hess's problems. And again, if you're not sure about what's up with the Hess's problems, check out the videos. I do have Hess's Law parts 1 and 2, so you can check that. Alright, so what is exactly involved here? For this reaction, you may notice that, wait a minute, the graphite is on the opposite side. It's in the product side of our equation. Which means when we look at this equation, the value of delta G is negative 394 kJ, but that's saying that the graphite ends up turning into carbon dioxide gas. That's the one way that it's going through. But the reality is, for us, in order to have these two balance each other out, this is what we're going to need to do. We're going to need to take this graphite equation, C plus O2 gets CO2, and we're going to have to turn it backwards. We're going to have to change direction, and that negative 394, yep, it's going to have to become a positive 394. So let's go ahead, let's try to fit all this in, and let's see where we go with it. Okay, so we're going to have, here's our carbon in the diamond, okay, plus O2 in the form of a gas, okay, plus okay, so here's carbon in the diamond with the O2 as a gas, and we end up plus CO2 in the form of a gas, okay, is going to get us
carbon in the form of graphite plus O2 plus CO2. Now, where did the oxygen and the CO2 come from? Well, this oxygen came from the diamond. Oxygen, notice how I marked them in red. Okay? And this carbon dioxide came from the reaction dealing with the diamond. So that's where it works out. Now, what about the CO2 here? Well, remember, we had to flip this. So our CO2 comes from the CO2 of the graphite. And our O2 is coming from this O2 from the graphite. Okay? So that's basically it. We switched it out. We switched it. Now, watch this, because this is a key part of solving this. You want to make sure that you have the correct number of moles, that these will balance each other out. Because if you do not have the correct number of moles, you're going to have to multiply whatever on the delta G. Let's say you had to add 2 moles of this, double what this is, then you would have to multiply this by 2. Now for this example, it's 1 all the way through. We don't have to worry about it. Now, let's look at the thing here. We have carbon dioxide on both sides of the arrow. We can cross those out. They cancel each other out. Now what happens if there was more than 1 carbon dioxide? Let's say this was 2 and this was 1. This cancels out. This goes from 2 to 1. Okay, but in our case here, these cancel out. And guess what? The O2s cancel out as well. This is good. This is wonderful news, because we end up with carbon in the form of a diamond ends up becoming carbon in the form of graphite. I should say Gr for graphite. Perfect. We're on the right track, because that's what they wanted us to do. So let's go back here, and if you notice, we're going to have to change this value. So if we take our delta G total, it's equal to the summation of the delta G of our products minus the summation of the delta G of our reactants. That's our basic formula. Now we can plug this in. What is our reactants? Well, our reactants, it's the diamond, right? So it's going to be minus 397. So it's going to be minus 397 kilojoules. Okay? And then over here, this is from the product, right? Our product that we got, our graphite. Well, our graphite, remember, because this was flipped, this is now going to become a positive 394. Now we have a positive 394 kilojoules. And then we have to combine those together. So we have a positive 394 plus a negative 397. We end up getting, at the end of the day, the delta G of our reaction of carbon going from a diamond to carbon going in the form of a graphite is going to equal negative 3 kilojoules. This, ladies and gentlemen, is our final answer. And because delta G is negative, guess what? It's spontaneous. But you're going to find I have another video where we cover delta S, calculating the delta S, using a very similar formula. Now, typically they will provide the delta G information for you. Okay, so you don't need to memorize it. All right? So, hey, I hope this helped you out, guys, and take care. Till the next time.